we will discuss about the type of melting furnaces. So you know that now you have prepared the mold, and now at parallelly what you are doing, you are also melting the material, and after melting the material, what you will do, you will pour this molten material into the sand mold cavity. So how the melting is performed? So melting is performed with the help of different type of furnaces, and this furnace is considered as the heart of every foundry, and these are refractory line vessels that contain the material to be melted, and it provides the energy to melt it. So mainly there are four types of melting furnaces in the metal casting. The first one is the Cupola furnace. You already have heard about the name of this Cupola furnace. It is one of the oldest type of furnace. Then we have crucible type of furnaces, and then more advances in induction furnace and electric arc furnaces. So first of all, we will discuss about the this Cupola furnace. So if you remember this furnace, that it has been used in foundries for the long time, and this is a long cylindrical shaped type of furnace, which is very high, very big in size, and it is lined with the clay bricks and blocks to protect the interior from furnace from enormous amount of heat, abrasion, and oxidation. So the abrasion, how the abrasion of inner wall occurs. This abrasion occurs due to the charging or loading of the material inside the cavity where the actual melting is performed. So this is a cylindrical shaped cupola furnace, and at one side there is a charging door, and there is a charging floor which is generally fitted to a belt conveyor system. So all the charge from is coming from here to from this side to this side, and with the help of the feeding mechanism and charge floor, all the charge is fed inside to the internal cavity of this cupola furnace. And this charge is mainly of you can say the ore of the metal, and this cupola furnace is favorable for melting or for making the irons and cast iron, as you remember. So this is so the charge is consist of iron ore, coke, and limestone. So what's the purpose of the coke? The coke is used to perform the combustion, and there is a flux which is the limestone. So what's the function of this limestone? So limestone reacts with the coal ash and other impurities, and it forms the slag. So what you do, so you take a crushed mixture of iron ore and other scrap material, and then you also mix that charge with coke and limestone, and then there is a blower. So this blower blows the hot air into this cupola furnace, and due to this hot air, the combustion of the coke takes place, and which also results in the reduction of iron ore, and whatever be the impurities present in the iron ore, coke, ash, so it get mixed with the limestone, which form the slag, and then this slag floats over here somewhat here, and the function of the slag, you know that it is similar to as we have studied in the welding process. So that slag basically covers the molten metal from the atmospheric contamination and other impurities present in the molten material. It also get mixed with the slag, and it floats on the surface, and there is at the bottom there is a tapping out, you can say tapping out mechanism, from which you tapped out the molten metal into the ladle. So ladle is placed here, and or whatever be the molten metal which has produced from the reduction of the ore, it flows down, and with this inclined surface, it can be easily tapped out, and then you can pour it into the this ladle, and then that ladle is sent to the other area where you can perform the rolling and extrusion of the material. So this is the Cupola's furnace, and very simple type of this furnace, and it has been used in foundries for a very long time. And now we will study about another very important type of furnace, which is known as the induction furnace. And this induction furnace works on the principle of electromagnetic induction, and it uses an alternating current which passes through a induction coil made up of copper in order to develop a magnetic field in the metal ingots plates inside the crucible, and the resulting induced current causes the rapid heating and melting of the metal. And this particular type of furnace is very widely used in foundries because they are of very high quality, and they are easy to operate, and they are very energy efficient. And uh, another advantage of this furnace that it can melt the material in small quantities of less than 1 kg, as well as metals available in larger volumes up to 100 tons. And the melting, this furnace is favorable to melt different materials like steels, cast iron, and aluminium alloys. So this is basically the schematic diagram of your furnace. So this is the main housing of the furnace, and there is a refractory material. The crucible is made up of refractory material. Generally, it's a mixture of graphite and clay, and then this particular central crucible is surrounded with the help of copper induction coils, and then you supply alternating current to these induction coils, and at the top of it there is a removable cover, so you can place this cover to protect the melting material from atmospheric contamination. Also, the force of electromagnetic this induction, this basically causes the mixing inside the molten metal, and this is a very can say easily available type of induction furnace, and it is very efficient, and it can be used to melt the materials available in smaller quantities as well as in the larger volumes up to 100 tons. So this is very common type of furnace used in foundry application. After this, we have another furnace, and this is known as crucible furnace. And these furnaces are made up of refractory materials such as ceramics, because they are exposed to very high temperature and have to withstand them satisfactorily. So, in this particular furnace, these are of three types. One is the first one is the lift out crucible type of furnace. Second one is your stationary pot crucible furnace, and third is your tilting pot furnace. And so in this particular furnace, the crucible is placed above the heated source to melt the metal, and uh, these furnace melt the metal without direct contact with the burning fuel mixture. So in this particular construction, you see that this furnace is made up of refractory lining or brick material, refractory brick material, and this particular enclosure is having a crucible which is made up of graphite material, and then you supply fuel such as oils and natural gases, and the mixture is burned inside this cavity, and then heat is liberated in this particular zone, which causes the melting of the material inside the crucible. And these furnaces are sometimes known as indirect fuel fired furnaces. And different types of materials such as non-ferrous materials like bronze, brass, and alloys of zinc and aluminium are melted inside these furnace. So this is a lift out type of furnace that you have to lift this furnace after the melting of material. So you can lift this crucible out of this furnace, and then you can use it like a ladle to pour the material into into the cavity for making castings. So this is a lift out crucible type of furnace. And then this is a kind of stationary pot furnace where the crucible is fixed and stationary, and it is meant for melting larger volumes of metal. And then after the melting is performed, after the melting is completed inside this crucible, you take a cup, or you take a ladle to scoop out the molten material from this crucible, and then you can pour that ladle into the mold cavity. Then we have third type of furnace, which is called the tilting pot furnace. And in this furnace, your crucible can easily be tilted with the help of a tilting mechanism, and there is a tilting handle, so you can rotate it, and gradually it results in the tilting of this whole furnace. And simply the heating is performed with the supply of combustible gases and oils. So here you don't have to lift out the crucible, or you don't have to scoop out the material from the crucible. Just you have to tilt the whole furnace. So it's relatively a very easy and safe type of furnace to work in the foundry. So, if you like the video, then please subscribe to my channel, share it with your friends, and don't forget to hit the bell icon for the latest updates. Thanks for watching my videos.